Hey everyone, welcome to Ash Framework, the power of declarative design. Before we get into it, I'm going to talk a bit about myself. I belong to the pets that you see pictured here. In the bottom right, you can see my beautiful wife Meredith, not a pet, hugging our two danger floofs. I live in Greensboro, North Carolina, and I enjoy reading books, playing video games, studying the Japanese language, and above all else, spending time with my family. As for what I do, I'm the author of Ash Framework, which is a resource-oriented declarative design application framework for Elixir. It's a mouthful. So what do we mean by application framework? So many folks are used to building their applications with web frameworks designed to help you build web apps. And in Ash, we take a different approach. It's a framework for building your application layer and deriving capabilities from that layer. It has extensions that extend into the web layer. For example, Ash JSON API and Ash GraphQL for building APIs. And those using Ash will often use Phoenix alongside it if they're looking to build user interfaces or interact in other ways with the web layer. And if you're not familiar with Phoenix, Phoenix is the gold standard for web frameworks in Elixir. It's kind of like Rails or Django. Well, Django's not a great example, but Rails. We all know what Rails is. So I'd also like to thank my employer, Alembic, for funding my work on Ash and my attendance at conferences. Alembic is an international software agency with deep expertise in web development, distributed systems, and wrangling complex software requirements. We combine great people with leading tech to help businesses build ambitious software applications simply, effectively, and sustainably. So if you're looking for help, you can find me afterwards and we can see what we can do for you. I'm going to talk a bit about Elixir. This talk isn't really about Elixir, but it is important that Ash Framework is an Elixir framework. And I'm not going to get into the technology behind Elixir that makes it awesome, but I'm going to talk about the impacts on me that make me prefer it, why I use Elixir, why I built my career around it. Primarily, we have simplicity. This is one of the biggest ones. It's an immutable language, it's a functional language, it's generally easy to write, it's generally easy to understand. It's also built on very tested technology. Elixir is built on top of Erlang, which has been around since the Stone Age. It runs telecoms and all sorts of things on the internet. And so it's not changing so rapidly that we're not still figuring things out, right? Elixir is on a very good foundation. We also have stability and performance. So Elixir runs on the Beam VM, which is extremely stable, with a technology called OTP built in that provides an actor model. So we call those processes. Everything in Elixir runs in a process, which inherently describes how to handle crashes, restarts, etc. And the Beam VM also handles scale incredibly well, which dovetails nicely into cost efficacy. So Elixir is very friendly in terms of resource usage, the Beam VM specifically. The internal process model is extremely good at leveraging available CPU and memory on a given machine. And this is actually really important because this is one of the things that you can sell to leadership at a company about why they ought to use Elixir. This is something that not your rank and file developers care about, but that will make a massive impact on the bottom line of any company that you work at. And the proof is in the pudding here, right? So Elixir saved Pinterest $2 million a year in server costs. That's insane. I mean, $2 million a year in server costs. We have Corey O'Daniel from MassDriver, who mentioned on Twitter, not so long ago, that they rewrote, that was 6 years ago, oh my God, time goes so fast. Anyway, they rewrote an AWS API gateway and Lambda service that was costing about $16,000 a month, and they rewrote it in Elixir. And it's running on 3 nodes that cost about $150 a month. So that's 12 million requests an hour with sub-second latency, 300 gigabytes of throughput a day. So Elixir is very powerful, very easy to use, and generally speaking, very friendly to the budget of any business. Live from the editing room, I had planned to start with a bit about a hypothetical future. If you read my talk description, you might have seen that. But I have pulled an audible, and we are instead going to start with a piece about balance. And since all good conference talks hit you with big facts, here is my big fact. 100% of absolutes are absolutely incorrect, including this one. So we're going to go through some examples, and I want you to keep in mind 2 things. One, most engineers with any amount of experience will already understand that these absolutes don't hold. But some people, you will find folks out there who think in these absolutes despite the repeated failure of that process. So I'm going to show you some bad examples, but before you argue too much, remember 100% of absolutes are absolutely incorrect. So depending on the context, maybe you actually do want to do the things that I'm showing you not to do, but bear with me while I use these to make a point. Let's start with one absolute. do everything in the database. Maybe better phrase is do as much as you can in a database. I know there's a lot of code up here. Don't worry about it too much. Let's say we're working on an e-commerce app, and a ticket comes in that says we want to automatically create a restock order when there are less than 10 items left in stock for a given product. So you're a clever person, you know all about databases, and you think, let's use a trigger. That way, no matter how an order gets created, we update the inventory amount and we insert a new restock order if there are less than 10 left in stock. So you can see here, after an order is created, we will modify the inventory to reflect the new amount. And then after that, if there are less than 10 things left in stock, we're going to create a restock order. So this strategy is future-proof, right? No, not really. Now, again, maybe in some contexts that trigger is enough, right? But generally speaking, as we build applications, they grow. Requirements get more complex, features get more complex. And it's important to understand that data changes do not equal domain logic. When you have a domain operation, one of the things that happens is some data might change. But that is not, in general, the entire thing. Sometimes it is. Sometimes says somebody wants to create a post, and literally all that you do is insert into a database table, right? But that's just because that's a simple operation. So let's say we were to get a ticket that comes in and says, we only want this restocking logic that we had to happen in the staging environment, or if the user who placed the order is an admin, or only if it's a Tuesday where the user who clicked the button is, right? These are the sorts of things we don't generally lower into like a trigger in our database. Okay, so we're gonna do everything in the application, right? We can't do it all in the database. We wanna be flexible, right? And the application's our most flexible layer of our stack. So we're gonna do everything in the application. So here we're looking at an early piece of order creation code. We're inserting an order for a given customer, and we want to make sure that the provided customer ID matches a real customer, right? That makes sense. So first we check, is there a customer with this ID? And if there is, we do an insert. So this is flawless, right? There's no data consistency issues with this approach. You sure about that? So this is the point of foreign keys. Right? And to give you an example, the database should have been in charge of enforcing referential integrity. That's a data concern. It's the sort of thing that should exist, that should be handled by the database, right? And the point here is that some things ought to be done in the data layer and some things are better suited to the application layer. Oh, I forgot a funny bit. So first we check if the customer exists, and then the customer is deleted, and then we place an order for a non-existent customer. Right? So these are the sorts of things that happen if you implement things in the wrong place. Some things belong in the application, some things belong in the database. So let's look at another set. Let's do everything on the client, right? So the client's very flexible, it's very performant. We get to use other people's computers to do our logic instead of our own computers. Like we pay for our own computers. They paid for their computers, so why not use theirs? So let's say we have an option to delete an order on our website, right? And we get a ticket that comes in and it says, only admins should be able to delete orders. So you go and you say, well, I'll just check if they're an admin before I hit that endpoint. Job done, ship it. So then we hit this delete endpoint to delete the order. So that's very secure, right? No, I'm afraid not. So this requires a server-side authorization, right? This is something that you can't leave up to a client for security reasons. Okay, fine, we'll do everything on the server then, right? Like if I can't trust the client, why would I do any of my business logic on the client? I should do it all on the server. So now, the client's unreliable. So the product team tells us, hey, we want to show a timer on the front end that's counting down for when a user's looking at a product that has a deal. So like that deal expires soon, and we don't want the client to run that, because we just saw it's not the source of truth on when a deal expires. The server decides when a deal's over, right? So here, we first calculate the seconds remaining, and then we start it's not updating. It's lagging behind me, that's fine. So we set an interval every 1 second, and then we send a message to the front end across a WebSocket that says, here's how many seconds you have left, right? But you've forgotten the speed of light. This is very important information. The fastest packet from New York to London is about 60 milliseconds. So the theoretical max round trip time, this is really complicated math, is 120 milliseconds. So that means your timer is always 10% wrong. This is because of the speed of light. Okay, the speed of light doesn't actually matter. I'm kidding. Nobody cares about a tenth of a second. The important bit here is that you've actually forgotten about the speed of 3G, right? So when you have things that communicate across the front end, the server-client divide, latency, internet connection, all these things matter a lot. And realistically, what you probably meant to do with that design is that the server sends up the time that it expires and the client counts down, right? So our business logic lives in multiple places. And again, the point here isn't like to take any one of these and like run with them. The point here is that it's all about balance, trade-offs, and compromise. When we're building our applications, things can run all over the place. So what's a framework to do? How do we help you build applications when application logic can live anywhere? So we need to help you build your domain logic, build your business logic, whatever you want to call it. But our applications, that's a new one. Our applications are executed everywhere. So we can't centralize the execution. We've already seen that. Some of our logic happens in a database, in a client, in a server, or in a third party, etc. But we can at least centralize the definition. All right, and this is where declarative design comes in. And this, declarative as a word is used in a lot of different contexts, and some people mean slightly different things by it, and that is why it's important to define terms. So when I talk about declarative, I'm talking about relative to imperative, right, or in contrast to imperative. So in imperative design, we prefer code, and in declarative design, we prefer data. We would prefer to model an operation, not write instructions. For example, in imperative design, we prefer to state instructions, and in declarative design, we prefer to state the end result. And an example is you might tell your child, pick up your toys, put your laundry in the hamper, and make the bed. Whereas in declarative design, you would say, your room better be clean when I get home, or there will be hell to pay. Something very important about this is that declarative design requires smart tools. This only works if your kid knows how to clean their room. Like if you've never taught them how to clean their room and you say, clean your room before I get home, that's not going to work. So declarative design requires tools that are capable of taking like a desired end state and getting you there. Another important thing about declarative design is that it is relative, okay? So this is a loop. This is how you might loop over a list in JavaScript. This is perfectly valid JavaScript. You can do this today. But there's a more declarative way to do it. Right? You can say list.forEach. Now this one is not, this is still a function. This is still sort of imperative code by some definition of that, but it is more declarative. You're not saying here's how you go across all of the items in a list. You don't say start at 0 and keep incrementing a number until you get to the end, right? You just say for each item, do this thing. And in the future, this window will shift. In the future, maybe imperative will be seen as spending 6 months building an app, and declarative will be seen as asking ChatGPT 42 to just make you a bunch of money. So these definitions shift, and they will continue to shift. Okay, so how do we put declarative design into action? And the best way to show this is I'm going to show you how we do it with Ash Framework. I'm not going to teach you how to use Ash Framework. I'm going to show you some concepts and some of the things that we do. So I mentioned that it's resource-oriented. So this is a resource. It's a very simple resource. It's a user resource. You can see we've got some Postgres code. It says it lives in the users table. We've got some attributes, like a user has an email and an ID, or some relationships, like a user belongs to an organization. So this is code, but ultimately this is data, right? Like this lives in an elixir file, but this is just defining some data that we can then read later. That's all that code does. It doesn't like do something. It doesn't create anything. It just defines some data that can be read by our application. So I can say, give me the attributes of a user, and it will give me back some data. It say, there's two attributes, one called email, one called ID. I can say, give me the relationships. Like it says, it belongs to an organization. I can say, tell me what database table this thing lives in. I say it lives in the users table. So this is the fundamental principle, this introspection. We define data structures that describe our application, and then later we read that to actually do stuff. And to see how this applies to data, we mentioned some things live in a database and have to happen in the database, and some things happen in our application. Well, let's say I just added that resource, that user resource to my app. It's the first resource I have, and so I can run mix ash.codegen. That's just there's a tool called mix when you're working with Elixir that like runs tasks that your application might define, and ash.codegen is one such task defined by ash. So mix ash.codegen, we say, give it a name that we added accounts. And you can see it says, okay, I'm going to go find your extensions, and I'm going to run ash codegen, and I'm going to create a migration. So a migration is a script that can take a database from one state to a new state, right? So for example, when now we've created our users, we're going to have to create a table to store those users in. And so this file contains this code, among other things. It says create a table called users, and add an ID field, and an email field, and an organization ID. And then we can say mix-ash.migrate to actually apply those changes to our database on our machines. And this is actually a cycle. This is the general way that we work when we're working with Ash, is we add something to our resource. Like if I went in and I said, actually, users also have usernames, I would run mix-ash.codegen, add username to users. That name is just a name for that we use to generate nicely named files. It's not actually technically used. But it'll generate a migration that adds that column to the database. So things live in the database, but we decide what lives in the database by definitions in our application layer. All right, let's talk about computation. This is what in Ash we call calculation. So a lot of times our domain logic, our business logic, the stuff that people pay for, is defined by an expression. Like the full name of a user is kind of, you could see it as domain logic or business logic. Or more, and a good example might be like a monthly total expense report is actually an expression. It's like the sum of all of my report's expenses, that sort of thing. And so expressions in Ash can be used in the database like this. So I can say, give me the users where their full name equals John Doe, and it will compute here that in the database. But it can also be run in memory. So if I say, given some user, calculate their full name, this is just going to do it in memory in Elixir. So because we have an abstract definition of the calculation full name, we can run it anywhere. And this doesn't exist now, but eventually we're going to have the ability to lift those up into JavaScript. So for instance, instead of having to send the knowledge, like if somebody has requests a page that has a user on it, and they want to know what the full name is on that page, you don't have to send it across the wire. You can compile your JavaScript with the knowledge of how to construct a full name given a user and have it do it on the front end. And you have centralized your definition while allowing execution of this domain logic to happen on the client. So actions are one of the most important ways that we can actually leverage declarative design. And this is one of the places that most people will bail on declarative design. You think the verbs in your system, like registering a user, modeled declaratively as data seems quite difficult. This is where you want to write like a script. You want to say like, well, first, get the email and then insert it into a table and then do all this sort of stuff, right? But we can actually model these declaratively. So we have a register action, and we say that it accepts the email. So we say, we already know what email is. I don't have to describe it any further than this. There's a thing called email on the resource. We're going to use that. And then we can add even more logic to it. We can say there's an argument called password. So this is a action-specific input. We can define constraints. We can say it's not allowed to be nil. We can say that it's sensitive, which tells the entire framework, every single place that might reference this is going to know not to log that, or not to allow it to be what we would call inspected, or like debug printed when a developer tries to inspect it. And we can also attach functional hooks. So like obviously, everything that you could dream up of doing, we haven't modeled declaratively. That's not the way that works. But you can say, okay, I'm going to do this special thing that will hash their password. So in this way, we can have our actions themselves defined and described. And what that means is I can take this action, I've re-simplified it here, and I can hook it up to a GraphQL with, this is actually all of the code that is required to put that action into a GraphQL API. I say that it has the object itself has a type, and that I want to put the register action into a mutation called register. I can do the same thing with JSON API. So I can say make a route that's at /user/register that exposes that register action, and that's all of the code that's required for that. I can define internal APIs. I can say there should be a function called register that takes email as an argument and allows me to register a user, all backed by the action definition, that declaration there. And all we had to define was just how to sort of project it into that other thing. How do I put this in a GraphQL? How do I put this in a JSON API? And if you've worked on applications, that have large APIs, what you've likely seen instead is tons of handwritten layers that map fields from one place to fields in another place and redefinitions of like, here's the fields on a user. The same list of things we display about a user exist in like 5 different places in a normal application. So given this, that definition of a GraphQL mutation, we define the entire thing. We know all of the errors that can happen. We know the shape of all of the inputs. We know how to filter them, how to sort them, all of that sort of stuff. That is literally those 1, 2, 3, 4, 5, 6 lines of code does the whole thing. The same thing works for JSON API. And you get more than just an API. You get an open API specification automatically. It's actually that much code. You have to install it and set it up, and then it's that much code. And this is going to be automatically documented, automatically typed, all of the inputs available to use, all that sort of thing. And we could do the same thing with our internal interfaces. We just have to use those 3 lines of code to say that we want a code interface that has a register function, and now I can say user.register in like my other places in my application. We can also make our business folks happy with insights. So let's say they're like, I want an architecture diagram, right? Well, we can describe the whole thing. We have the entire surface area available to us as data, not scripts, but data. And so this is an example from a real application of mine. This is the ledger section of an application of mine. So you can see we have accounts and we have balances. And I'm going to zoom in on this little bit down here. These are domain operations available in this, right? So if you tried to do this with just your database, right, like give them a data diagram, it would not contain these things. These are domain operations, not data operations, and that's very important. And you can see we can do the same thing. This is, okay, I said you can see, that's not true. This is not very easy to see. But I'm going to zoom in a little bit here. We can generate what's called policy diagrams. So Ash comes with a policy authorizer that allows you to lock down access on any given resource, on any given action, all sorts of things. Honestly, it's too much to describe right now. But if you could do a security audit like this, you could provide a business person or your InfoSec folks and a breakdown of, for every given resource, the entire workflow for how we decide if any given action is executed. And that is literally impossible to do if your authorization code is a bunch of functions. You can't do that, not realistically. Then the source of truth is the code. But we can do that because it's data. I just wrote a script that will go over all of your policies and figure out what the flow looks like and put it into a chart. It's actually not very difficult. We can get entire application components for free. Because I know all of the resources in your system, I know what they look like, I know what their actions are, I know what their inputs are, I know what data they have so I can render them. This you can get this is a 0 configuration admin UI that you just get. Because all we have to do, it's literally a big loop over all the resources and figure out what they do. There's a user resource. There's a create action on user. It takes these inputs. It's actually not that hard because it's data. So what this looks like in an application architecture is this is the layer that we work in when we're working with Ash. We build these definitions, and the tooling that surrounds it can derive a bunch of other stuff that we need. So the JSON API is derived, the GraphQL is derived, the admin interface is derived. We have interactions between other parts of our, other things that we need to back our resources automatically derived. So like, how do we talk to Postgres? That's figured out for you. We have in-memory databases, CSV data layers, so you can back a resource with a CSV file. We have all sorts of things. We have Ash JSON API wrapper, so that you can back a resource by something somewhere else. And this sort of, you don't have to do any of that. You define a minimal amount of configuration that maps your resource to what it looks like to work with that thing. And we have a sort of workflow here, which is we start with a DSL, some description, right? DSL means domain-specific language. But in this case, we generally, in Ash, we just mean a description of something. We use the data structure that's provided to ask questions about that, and we derive a bunch of stuff. And so from this, we can get internal code APIs, JSON APIs, GraphQL APIs, application components like admin interfaces and charts and graphs and other interactors. We can generate our database structure. And what you saw was really simple stuff, but you can put trigger definitions, you can put custom indexes, you can put stored procedures, all sorts of those things directly in the resource, and it will ensure that any given date, like that when you generate your migrations, that those things are up to date. And so you can have one source of truth, your resource, for everything. We can build reusable building blocks. So early on, I showed you a change called hash password, right? That thing can be used in any given place where you might want to hash a password because it has a defined contract of what it means to hook into an action. We can do integration drivers. So if you wanted to hook up to Postgres, we have Postgres, SQLite, MySQL. You don't have to like differentiate your application. There are different features in each of those, and so I'm not suggesting that it's like a magical integration layer where you don't have to know what the difference between those databases are. But you don't have to write some sort of integration driver. And we also can do smart UI components. This is something our community is working on that's relatively new, but there's a thing called Ash Table, where you just give it a resource and a read action, and it will generate a filterable, sortable, paginatable table automatically. And that's a bunch of code that, if you've written that, you know that you hate writing that, and it should have been free the first time. You're like, why am I writing this again? Everybody has this table view. Why am I writing it? All right, that's all I got. I think we have time for questions. I think I kind of blasted through that. Yeah. Oh, okay, that's not bad. So I've got some QR codes here. All of these will hack you if you use them. All right. But yeah, we have a Discord server, it's very active. So if you're interested in getting started with Ash, or even just asking questions of me, feel free to join that Discord server. We've got a lot of people there that will help you out. I can take questions, if people have them. In the back, in the hat.
Tell you what, I'll do the microphone thing.
He's bringing you a mic.
So for the GraphQL API and for the OpenAPI, or the OpenAPI compatible JSON API, do you all generate as well the OpenAPI spec or the
Yes.
schema file?
Yeah, the entire thing's generated. Yeah, it's really convenient. And actually for folks who are interested in the AI hype train, if your API has an OpenAPI specification, you can generally just like hook it up to ChatGPT as like an external source of something. You can upload that and it will just call your API. So OpenAPI specifications are increasingly more and more valuable over time. They don't really do that with GraphQL APIs. So like, maybe REST is making a resurgence on that front.